Jimu-1, a floating airship independently developed by the Chinese Academy of Sciences, has been carrying on vapor observation above Lake Nam-to, the second largest lake of the Tibet Autonomous Region, since May 9th, 2019. At 6:01 AM, May 23rd, Jimu-1 reached an altitude of 7,003 meters above the sea level. It is said to be the first floating airship of its kind and size in the world to arrive at such an altitude. A floating airship is a type of unpowered aerostat that gains its lift through the use of a buoyant gas. It is usually linked with an anchor on the ground through a cable. Jimu-1 has a volume of 2,300 cubic meters. Its inner space is divided into two parts. The upper part contains 1,400 kilograms of helium, while the lower part contains only normal air. Its powerful upthrust derives from the fact that helium is lighter than normal air. When Jimu-1 floats on higher altitudes, operators can maintain the pressure difference in the airship within safe limits by releasing some air from its lower part. Jimu-1's surface is nearly 2,000 square meters, which is made of composite fabric that can withstand temperatures as low as -70 degrees Celsius. A black cable is used to control its movements whenever it is to take off from the ground or station at certain altitudes, ensuring that it will not be affected by the wind. There are two overhead lines within the cable, functioning to power the entire airship. As far as its overall design and its materials are concerned, Jimu-1 is an indigenous airship. Most of its control system, power system, cabin design, and ground mooring facilities are independently developed by China. Jimu-1 is only the first of 3 airships in the pipeline. The Chinese Academy of Sciences, the airship's creator, will launch Jimu-2 and Jimu-3 in the future. Jimu-2 and Jimu-3 will fly even higher, which means their systems and the technologies involved will become more sophisticated and complex. These floating airships will serve the Qinghai Tibet research mission. They can facilitate deeper researches on the Qinghai Tibet Plateau and the Himalayas. In particular, they can monitor climate and environmental changes in the water tower of Asia, as the Qinghai Tibet Plateau is commonly known, and facilitate decision-makings that ensure the sustainable development of the plateau. Behind Jimu-1's new altitude record is the perseverance of Chinese scientists and engineers. They endured lower temperature, hypoxia, blizzard, intense solar radiation, and night shifts, among other hardships. Jimu-1 housed a list of scientific and experimental equipment which can monitor a variety of indicators regarding atmospheric physics and atmospheric chemistry during Jimu-1's takeoff. Since the onboard equipment can collect atmospheric composition data at an altitude of 7,000 meters above the ground, they will bring new possibilities for researches on the water, ecology, and human activities on the Qinghai Tibet Plateau. The onboard scientific equipment can carry out vertical profile and above-ground observations, opening a new chapter in China's history of floating airship monitoring experiment. They will also provide invaluable experiences for the design and technological upgrades of airships in the future.